three-phase cycloconverters. So again, two types, that is three-phase to a single-phase cycloconverter and three-phase to three-phase cycloconverter. This is the circuit for three-phase to single-phase cycloconverter. I want to step down the frequency from 60 Hz to 30 Hz. If 60 Hz takes 2 pi radians to complete one cycle, then 30 Hz, which is nothing but half of the frequency, then it will take double the time period, that is 4 pi radians, in which 0 to 2 pi is a positive output, 2 pi to 4 pi negative output. This is a positive converter and this is a negative converter. The positive converter operates for half the period of output frequency and the negative converter operates for the other half the period. We have AB. For AB voltage in positive, T1, T6 will operate, and for BC, T3, T2 will operate. For CA positive voltage, T5, T4 will operate. If we want to get negative voltage for minus VAB, T1 dash, T6 dash from the negative converter will operate. Negative VBC, T3 dash, T2 dash will operate. Negative CA, T5 dash, T4 dash will operate. Let this be alpha. Up to 2 pi, it's positive. P converter should operate. From 2 pi to 4 pi, N converter should operate. At alpha, VAB is positive, so T1, T6 can be turned on at alpha. So when I turn on, this is my output voltage. Now, again at alpha, this is I have taken that 60 degrees, then I'll take 60 degrees from here. TBC, T and T2 can be turned on. Again, here I can turn on VSC after 60 degrees. We got half of the cycle. To get negative response, I need to operate the N-type converter. VAB is positive. I need to get a negative. Then I need to turn on T1 dash and T6 dash here. This is by turning on T1 dash, T6 dash. Here VBC is positive. Now I need to get negative VBC. So T3 dash and T2 dash I need to turn on here. T3 dash, T2 dash. VAC is positive. I need to get negative VAC. Then T5 dash, T4 dash from N converter I need to turn on. This is T2, T5 dash and T4 dash. When you observe this output response, the output voltage is not purely sinusoidal, and as a result, the output voltage contains harmonics. And the input power factor depends on the delay angle of the thyristor and is poor essentially at the low output voltage ranges. The output voltage of a cycloconverter is basically made up of segments of input voltages, and the average value of a segment depends on the delay angle for the segment. If the delay angles for the segments were varied in such a way that the average values of segments corresponds as closely as possible to the variations of desired sinusoidal output voltage, the harmonics on the output voltage can be minimized. The control of AC motor requires three-phase voltage at variable frequencies. The cycloconverter can be extended to provide three-phase output by having 6 three-phase converters as shown in the schematic diagram here, and each phase consists of 6 thyristors as shown in this figure, and it requires totally 18 thyristors for three-phase to three-phase cycloconverter. If 6 full-wave three-phase converters are used for this circuit instead of this circuit, then we require 36 thyristors.